Welcome to our first lesson, and this lesson is on using properties of real numbers. So, in order to use properties of real numbers, we need to know what the real number system consists of. And the real numbers has several subsets of other number systems, and those are listed here for you. The most basic set of numbers is the natural numbers, and those are the numbers that you think about when you first learn to count. When you're a little baby and you have a birthday, your very first birthday, the first number you probably learn is 1. And then you have another birthday and you turn 2. So the natural numbers that's the very first number system that you learn, and that's usually just by counting when you have birthdays. The next number system or the subset of numbers is the whole number system. And the whole numbers include all of the natural numbers, but you add the number 0 to that. So from the whole number system, we move out one more layer, one more ellipse here into the green layer. And that number system includes all of the natural numbers plus 0 in the whole numbers. And then it also includes the numbers to the left of 0, or the negative numbers, which are called the integers then. So all of the positive and negative natural numbers in 0 are called the integers. And if we move out one more layer into the pink rectangle here, we have the rational number system. And the rational numbers are any numbers that can be represented by a fraction. So those are things like 3/4 or any decimal that terminates or any decimal that is repeating. Okay, so those are the rational numbers. They can be represented by a fraction. Over on the right-hand side in the purple square, we have the irrational numbers, and the irrational numbers cannot be represented by a fraction. Those are things like square roots that cannot be simplified, decimals that don't repeat, things like pi, or the letter e when you get to know about the natural logarithms. The base e is another non-repeating decimal. So the set of real numbers consists of all of those subsets of numbers, and if you put those all together, that's what we call the real number system. So let's look at some examples. It says identify the subsets of real numbers to which each number belongs. So we're going to start with -5 for letter A. And -5, it is a real number. If we start at the very outer edge here, it is a real number. And then let's move our way in. It's also rational. It can be represented as a fraction, -5/1. It's also an integer. It is not a natural number. It is not a whole number because it is negative. So the furthest down in that we can drill is the integer. How about 25? 25, it's a real number. It's a rational number. It's an integer. It's a whole number, and it's a natural number. So that has a whole bunch of subsets of numbers to which it belongs. How about -√5? Well, this one, it's a real number, but it's also irrational. So that one only has 2 number systems. So here are a couple for you to try. Go ahead and pause the video and try to figure these out on your own. And I'll give you the answers when you come back. Alrighty, hope you gave that a try. So letter A, -16, is real. It's rational. We can represent it as a fraction. It's also an integer. The number 32 is real. It's rational. It is an integer. It's a whole number, and it's a natural number. And then letter C, -√20. That one is a real number, and it's irrational. All right, so here's some properties, and these properties of real numbers are used when you're solving equations or simplifying expressions, and also if you're trying to prove things. So some of the properties of addition and multiplication. If you have A, B, and C and they're real numbers, there's a property called closure. And closure means if you add or multiply 2 real numbers together, you're going to get a real number answer. And that's called closure. As long as the answer you get is still a real number, then that's called closure. So we would say addition is closed or multiplication is closed in the real number system. The commutative property says that it doesn't matter what order that you add or multiply numbers. So the commutative property deals with the order in which you add or multiply, and it doesn't matter what the order is. And then we have the associative property, and the associative property deals with grouping or associating. Doesn't matter what ones you group together. If you add A and B and then C, you'll get the same answer as if you add B and C and then A. Same thing with the multiplication of that. So that's the associative property. And the distributive property, when you see that one, it sometimes goes where you'll start with this left-hand side and get the right-hand side where you're multiplying the A through the parentheses, so you get rid of your parentheses. Sometimes you'll see it the other way, though, as well, where it's factoring out a common factor so that you have parentheses, and that's the distributive property. And then two additional properties of addition and multiplication are the identity and inverse properties. Now the identity property says if you start with some real number A, what do you add to it to end up with that same number? So 0 is called the additive identity because you want to start and end with the same number. And it doesn't matter which order you do that. The multiplicative identity then, what do you multiply A by to get A back? And 1 is called the multiplicative identity. So then the inverse, and I know these are confusing. Sometimes identity and inverse get mixed up. An inverse is something that you add or multiply to a real number to end up with the identity. So we said 0 is the additive identity, so we want to end up with that when we find our inverse. So what do we add to A to end up with the additive identity of 0? And it's the opposite of A. And then for multiplication, we want to end up with a multiplicative identity, which is 1. So the inverse of A is the reciprocal of A. Okay, and A can't be 0 because we can't divide by 0. So now that we have some properties of real numbers, we can use those to go ahead and simplify some algebraic equations or expressions. So it says identify which property is being demonstrated. Well, in letter A, we have 3 times 8 being the same as 8 times 3. Either way, you get 24. So this has to do with the order in which you multiply. And the order does not matter. And we said that was the commutative property. In letter B, we've got some parentheses here. And we're multiplying the 5 through the parentheses. So that looks like the distributive property. Letter C, we've got parentheses as well, but we're grouping the numbers differently. We have 12, 20, and 30. And on the left, we're grouping 12 and 20, but on the right, we're grouping 20 and 30. So this is a grouping property, so remember that was the associative property. Here are 3 for you to try. Go ahead and pause the video, and I'll give you your answers when you come back. Alrighty, hope you gave that a try. Let's take a look. So we have 23 plus 10 being the same as 10 plus 23. Hopefully you got that that was the commutative property of addition. Letter B, we have some parentheses on both sides, but it looks like we're distributing the 1/4 through the parentheses, so that's definitely the distributive property. Letter C, what's going on here? We're taking 7 times -5 first on the left side, but on the right side we're taking -3 times 7. And so that one looks like we're associating different numbers together. And so that one is the associative property. Example 3 says simplify each expression, identify which property you used for each step. So letter A, we've got 4 numbers we're adding together. So we're going to start with those 4 numbers, and you can use a different order if it makes the numbers easier to add together, perhaps in your head. And it looks to me like 12 and 18 you can add together easily, and 4 and 56 you can add together easily. So first of all, we used the commutative property to go ahead and reorder those. Let's see if we can get this to work here. I need to find my answer. There it is, the commutative property of addition. So we used that, and then we used the associative property because we're associating different numbers together. And then we just added those. We simply added those to get our answer. How about for letter B? Let's take a look at that one. 5 times 23, we're going to write that as 5 times 20 plus 3. Well, we're just breaking up 23 as 20 and 3, so that's really not a property. Then we're going to take 5 times 20 and add 5 times 3. Well, that one now is the distributive property. We're getting rid of the first set of parentheses. And once we do that, then we're just simply multiplying, and then we're doing addition. Example 4, finding inverses of real numbers. This one says find the additive inverse of negative 7a. So remember, an inverse, we want to end up with the additive identity, which is 0. So what do we add to 7a, negative 7a, to end up with 0? Well, it's just the opposite of negative 7a, which is positive 7a. So the additive inverse then is positive 7a. How about part B? It says find the multiplicative inverse of 5n over 12p. Well, what was the multiplicative inverse? The inverse was 1. So what are we going to multiply this by to end up with 1? Well, we're going to need a fraction, right? And what's that fraction going to look like? Well, it's just going to be the reciprocal. And the reciprocal fraction is 12p over 5n. So that is the multiplicative inverse. And lastly, we have an application in finance. It says we have DVDs on sale for $11.95. And if we're going to get 5 of those, they want you to use the distributive property to mentally calculate the total cost without a calculator. So what we want to do is write an expression for the cost of those 5 DVDs in a way that will allow us to do this in our head. So this is really close to $12. In fact, it's only 5 cents less than $12. So if we took 5 times, and then in parentheses maybe 12 minus a nickel, because it's 5 cents short of $12, this would be $11.95 in the parentheses. Well, now we can use the distributive property, and 5 times 12 is 60. 5 times a nickel is 25 cents. So we have $60 minus 25 cents. Well, if you take 25 cents away from $60, you have $59.75. So we did that in our head, didn't need a calculator, and the total cost is $59.75. So there you have it. We'll see you in class.